Hello students, welcome back to the concept of differentiability. Okay, this is the last aspects of the differentiability. Okay, that is mean value theorem. In the mean value theorem, you are going to learn two theorems. The first one is Rolle's theorem and another one is Lagrange's mean value theorem. Okay, so generally we can call it as a mean value theorem. Okay, first of all, I'd like to explain the Rolle's theorem. In the Rolle's theorem, just initial graph I drawn here. Okay, the Rolle's theorem, for the Rolle's theorem, the basics you required is let the function f from a comma b to real number system R. Okay, I'd like to define this one. Here the domain is a comma b. I'd like to define this is nothing but a, it is nothing but a b. Means these are domain values, that's why it is on the x-axis. Okay, and after that two real numbers, means it is nothing but a range values, y values, it will take the values. Okay, after that, for step by step based upon the condition, I'd like to explain the Rolle's theorem. That is, f of x is continuous, f of x is continuous on closed interval AB. Means in between these two values a and b, the graph is completely continuous. Means there is no break or there is no jump in the graph. That is continuous in a closed interval. I am mentioning the closed interval. Okay, after that, f of x is differentiable on open interval AB. Means on this particular interval a and b, endpoints are excluded. Endpoints are excluded means excluding both the endpoints in between a and b, the f of x is differentiable. Means whenever you are going to check for any point in between a and b, the graph is differentiable. Left hand derivative is equal to right hand derivative. Got the point clearly? After this one, okay, I'd like to draw a tangent parallel to the chord, and the tangent is parallel to x-axis. Okay, if the tangent is parallel to x-axis, then the slope will be 0. Means this point, I'd like to take this point as a C. Now it is this, for A it will be f of A. B, the range point will be f of B. After that, this is nothing but a, I'd like to take it as a f of C. Okay, now concentrate on the board. Here f of x is continuous in a closed interval, f of x is differentiable in an open interval, then f of A is equal to f of B. Whenever I am going to substitute these two values, I need to get, whenever I am going to substitute these two values in the given function, I need to get the same value. That's why, see how the same value on the y-axis, A will be, this is the A value. Again on the y-axis, this is also f of b. F of A and f of b are same. Okay, then I need to write all the conditions of Rolle's theorem. Rolle's theorem are satisfied. It is satisfied. There exists a point, that is f dash of c is equal to 0. Means the derivative point, the tangential point is nothing but a derivative at that point, that is equal to 0. Why? Because slope of that tangent, whenever the slope means our tangent is parallel to x-axis, its the slope will be 0. Means if the slope is 0, means derivative at that point will be 0. That's why f dash of c equal to 0. And this C point is always belongs to the open interval AB. Then we can say it as all the conditions of Rolle's theorem are satisfied. What are the key points of the Rolle's theorem you need to understand? Here the key points are f of x is continuous on closed interval AB. means on closed interval AB it is the first condition. The next one is f of x is differentiable on open interval AB. This is the second condition. Next, f of a, whenever these 2 points a and b values, whenever we are substituting in the particular function, we are getting the same value. Then all the conditions of Rolle's theorem are satisfied. There exists f dash of c equal to 0. Then c belongs to a comma b, means c is the particular point that must be in between the interval, open interval AB. Now let's see one example. Focus on the board. Verify Rolle's theorem for the function y is equal to x square plus 2, a is equal to minus 2, b is equal to plus 2. Okay, what I told in the theorem, f of x is continuous. F of x is continuous on closed interval minus 2 comma 2. Why we are writing it is continuous? Because it's a polynomial function. We already learned all the polynomial functions are continuous. That's why f of x is continuous on minus 2 comma 2. F of x is differentiable on open interval minus 2 comma 2. Okay, after this one I need to write derivative of the function f dash of x. What is f dash of x? Means f of x is x square plus 2. What is derivative of f of x? F dash of x square derivative 2x, 2 derivative will be 0. After that I need to calculate f of a. What is f of a? F of a value is minus 2. Not in the derivative, I need to write in the function. It is minus 2 square plus 2 is equal to, 2 square will be, minus 2 square will be 4, 4 plus 2, 6 it is. F of b, what is f of b? F of 2 here, it will be 2 square plus 2 is equal to, 2 square will be 4, 4 plus 2 will be 6. Means f of minus 2 equal to f of 2. Means all the conditions of Rolle's theorem are satisfied. If all the conditions of Rolle's theorem are satisfied, what I need to write? F dash of c must be equal to 0. I had to write. I already told in the theorem. Okay, f dash of c equal to 0. What is f dash of x? 2x. F dash of z? 2z. F dash of c, I need f dash of c. It will be 2c. 2c is equal to 0. Means c is equal to 0 by 2 will be 0. Whether this 0 value belongs to the open interval minus 2 comma 2? Yes. In between minus 2 to plus 2, 0 is there. Got it? The next aspect is mean value theorem or Lagrange's mean value theorem. Okay, the graph is a little bit different from the Rolle's theorem. It is the next version of the Rolle's theorem. We can call it as a mean value theorem as well as Lagrange's mean value theorem. Okay, I drawn the graph already. Here the curve is like this. Now the f of a, means this particular point is nothing but a f of a. This is for the b, it will be f of b. Okay, now for this particular point, means this is nothing but a point of c here. Okay, means the tangent is parallel to the chord here. Got the point clearly? Means whenever I'm going to take the particular point here, I need to take a vertical line. Okay, the vertical line will be like this. Okay, fine. This is a point at c. Okay, now concentrate on the board. Here also the statements will be same. Okay, f of x is continuous on closed interval AB. Okay, you can observe the graph clearly. In between a and b, the graph is continuous. Okay, f of x is differentiable on open interval AB, means end points are excluded. In between a and b, for all the points it is differentiable, means left hand derivative is equal to right hand derivative. The next condition is here, this is f of a value on the y-axis, this is f of b value on the y-axis, this is f of a, this is f of b. Means easily you can say f of a is not equal to f of b. Okay, what was the condition in the Rolle's theorem? In the Rolle's theorem, f of a equal to f of b, then Rolle's theorem satisfied. Here, f of a not equal to f of b, then which will leads to Lagrange's mean value theorem. Okay, now anyhow I need to find the slope of a tangent, means at what point the tangent is there, that tangent is parallel to the chord I need to calculate. Okay, if the this tangent is parallel to the chord, means the slope of the tangent is nothing but a slope of the chord we can find. Okay, for that reason, whenever 2 points are given, how to find the slope of a tangent, you know already the formula, y2 minus y1 divided by x2 minus x1. Got the point clearly? Okay, here instead of calculating the slope of a tangent, to this tangent, the parallel to what chord is there, I need to calculate the slope of the chord. What is y2 minus y1? Yes, it is nothing but a f of b, y2 minus y1, f of a. What are its domain values, x values you need to say. What's the domain value of f of b? It is b. Okay, what's the domain value of a? F of a, it will be a. Okay, this is nothing but a f of b minus f of a divided by b minus a. This is nothing but a, that is a tangential point f dash of c. Got the point clearly? Okay, this f dash of c means c value is also, this value is belongs to the open interval a comma b. Why it is an open interval? Why? Because f dash of c is nothing but a derivative point, that is nothing but differentiable on the open interval. That's why c belongs to open interval a comma b. Concentrate on the board. I'd like to discuss the example about mean value theorem. Verify mean value theorem for the function f of x equal to x square in the interval 2 comma 4. Okay, initially it will not be given that like a verify LMVT, verify Rolle's. We need to understand it. Okay, first of all I'd like to write f of x is continuous. F of x is continuous on closed interval 2 comma 4. Why? Because given function is a polynomial function, it is an upward parabola, that is continuous. Okay, f of x is differentiable on open interval 2 comma 4. After that I need to calculate f dash of x. What is f of x? X square. F dash of x will be, derivative will be 2x. Fine. After this one I need to calculate f of 2, means f of a. What is f of a? F of 2 means it will be 2 square. 2 square will be 4. Okay, f of b means, what is the upper limit value? 4. F of 4, what is the 4 value? F of 4. F of 4 will be 4 square, it will be 16. Means what we got the value, f of 2 is not equal to f of 4. Means it will not satisfy the conditions of Rolle's theorem, means which will leads to a Lagrange's mean value theorem. Okay, for that reason I'd like to write f dash of c is equal to f of b minus f of a divided by b minus a. Okay, concentrate. F dash of c is nothing but f dash of x is 2x, f dash of z is 2z. What is f dash of c? F dash of c is nothing but a 2c. Got it? What is f of b? F of b is 16. Okay, f of a, its value is 4. Okay, then denominator b minus a means 4 minus 2 I had to write. 4 minus 2. Okay, it will be 2c is equal to 16 minus 4 will be 12 divided by 4 minus 2 will be 2. 2c is equal to 12 by 2 will be 6. C is equal to 6 by 2 will be 3. Whether this 3 value belongs to the open interval 2 comma 4? Yes, which belongs to 2 comma 4. Means the value 3 is in between 2 and 4. Okay, got it? Focus on the board. I'd like to discuss some of the exercise questions here. Verify the Rolle's theorem for the function f of x equal to x square plus 2x minus 8. The given function is a polynomial function. If it is a polynomial function, means it must be continuous as well as differentiable. That's why I would like to write f of x is continuous on closed interval minus 4 comma 2. F of x is differentiable differentiable on open interval minus 4 comma 2. After that I need to write f dash of x, its derivative I had to write x square derivative 2x, 2x derivative will be 2. Got it? After this one I need to check f of a and f of b. What is f of a? F of a will be lower limit f of minus 4. What is f of minus 4? I need to substitute in the given question, not in the derivative, in the given question. Minus 4 square plus 2 into minus 4 minus 8. Okay, it will be 16 minus 8 minus 8. I got the value 0. Got it? Now in the similar manner I need to calculate f of b. F of b is nothing but a f of 2. Upper limit value, it will be a 2 square plus 2 into 2 minus 8. 2 square will be 4. 2 into 2 will be 4 minus 8. 4 plus 4, 8 minus 8 is 0. It means f of minus 4 is equal to f of 2. Means all the conditions of Rolle's theorem are satisfied. That's why f dash of c is equal to 0. All the conditions of Rolle's theorem are satisfied. F dash of c is equal to 0. F dash of x is 2x plus 2. F dash of c is, instead of x, c is there. That's why 2c plus 2 is equal to 0. After this one, 2c is equal to 2 on right hand side minus 2. C is equal to minus 2 by 2. Then c value will be minus 1. Whether minus 1 is in between the open interval of minus 4 comma 2, yes, in between minus 4 comma 2 minus 1 is there. Got it? Focus on the board. Here they asked, examine if Rolle's theorem is applicable to the given function. Okay, I drawn the graph already. Now focus on the board. See, the given function is f of x equal to greatest integer function x. Greatest integer function x. I drawn the graph of greatest integer function for x belongs to 5 comma 9. Just observe the graph. For what point the given function is continuous or discontinuous. See, there is for 0 there is a discontinuity, for 1 discontinuity, for 2 discontinuity, in between 2 and 3 there is a continuous, but for 3 again discontinuous, for the 4 discontinuous. Means for all the integral values greatest integer function is discontinuous. Based upon this graph you can write very easily, given f of x is not continuous on 5 comma 9, not continuous on 5 comma 9. What are the point of discontinuity? What are the point of discontinuity means 5, 6, 7, 8, 9. For all these points the given function is not continuous. Whether you understood the point clearly, not continuous. Therefore f of x is, if it is not continuous, means f of x is not differentiable. Next, after the point not differentiable, then I need to check f of a means f of 5. What is f of 5? Greatest integer function 5 will be 5. F of 9 will be greatest integer function 9. Its value will be 9. Means what I have to say, f of 5 is not equal to f of 9. Means all the conditions of Rolle's theorem are not satisfied. That's why Rolle's theorem is not, yes, I need to say not applicable. Got it? Concentrate on the board. In the similar manner, they given one more example. F of x equal to greatest integer function x for x belongs to minus 2 to 2. Means we can write easily f of x is what? Not continuous on closed interval minus 2 to 2. Means for what point these are discontinuous? Not continuous at given function. F of x is not continuous at, what are the integer in between minus 2 to plus 2? Minus 2, minus 1, 0, 1, 2. Because of that reason, if it is not continuous, means f of x is not differentiable. f of x is not a differentiable, then moreover I'd like to calculate f of minus 2. What is f of minus 2? Greatest integer function minus 2, it will be minus 2 only. F of 2 will be greatest integer function 2, it will be 2 only. Means f of minus 2 is not equal to f of 2. Means what I have to say, all the conditions of Rolle's theorem are not satisfied. That's why Rolle's theorem is, yes, you need to say not applicable. Got it? For one more function, I need to check whether the Rolle's theorem is applicable or not. The given function is polynomial function. That's why f of x is continuous on closed interval 1 comma 2. Okay, because it is a polynomial function. F of x is differentiable on open interval 1 comma 2. After that, again f dash of x I need to check. What is f dash of x? X squared, it will be 2x. Got it? After that, I need to check f of a and f of b. F of a will be f of 1. What is f of 1? It is 1 square minus 1 will be 0. F of b value will be 2. It is f of 2 means what I write the x value? 2 square minus 1, it will be 4 minus 1, it will be 3. Got it? Means f of 1 is not equal to f of 2. Therefore, Rolle's theorem, you need to say, see, continuous differentiable, but f of a is not equal to f of b. That's why Rolle's theorem is not applicable. Got the point clearly? Okay. Try to solve all the problems and comment on the video, like, share with your friends. Thank you one and all.